Hi everyone, I hope you are doing well. This is the exam review, exam 2 review class. So this our exam 2 um, the content will consist from the chapter 6 to 10, the module, and you know that that would be until week 8. So we have the exam. So in the following recording of this lecture are not necessarily that I touch all the questions or all the content that would be in the exam, but mostly as far as I can remember, I tried to touch to give you an overview and a revision, so reintroduce all the materials that would be helpful for you to qualify or succeed in your exam. So you have to read and also watch the videos in the weekly module that you have right now, and also read the content to do a better job in the exam. But I hope that you will get very fruitful information from here, and let's begin. So in the module 6, you are familiar with atmospheric moisture, and from the atmospheric moisture you must have heard that latent heat and sensible heat. What is the difference between latent heat and sensible heat? So here's the thing: the latent heat, that you need an amount of heat to change the state of matter, but sensible heat is something that you need the amount of heat to raise the temperature of that substance, such as the latent heat. We can say that ice melt into the liquid, that's latent heat. But ice 0 degrees centigrade and liquid water is also 0 degrees centigrade. The amount of heat in this process you need, that's called latent heat. On the other hand, you are heating the ice, and the ice is melting down and then becoming liquid water, and then water become vapor, the 100 degree centigrade. So 0 degree to 100 degree, that's the raise of temperature. That's the difference in temperature is sensible heat. So amount of heat you need to raise the temperature of any substance, that's sensible heat. So this is the difference between latent heat and sensible heat. So you need to know that. And another thing, four state: so melting, freezing, evaporation, and condensation. And another two are most important, that's sublimation and deposition. So we know melting, evaporation, freezing, and condensation. You all already know that. But please bear in mind that sublimation. What is sublimation? Sublimation is that something, the ice is directly going to vapor. Ice supposed to go the liquid phase first and then vapor phase. No, the ice directly going to vapor phase, that's sublimation. On the other hand, oppositely, vapor directly becoming ice, that's called deposition. So we have snow. When we have snow is directly deposition because water vapor crystallize and become ice. And the sublimation is something that we can see the real world when snow outside and the sky is clear and sunlight. So you see that ice is not melting, but ice is reducing, because the snow is reducing because the sublimation process. So I would strongly recommend you to know all this. And another thing, that evaporation is a cooling process for the environment. Why that happened? Because when evaporation happens, water molecule absorb the heat from the environment. That's the reduction of heat of the environment. That's why when evaporation happens, it means that environment become cool down. That's why evaporation is cooling process. And when condensation happens, that means water molecule release latent heat, and that latent heat go to the environment, and extra heat make warmer to the environment. So condensation is a warming process for the environment. So this difference you need to know. I believe that Dr. Weichel lecture represent the process determining the amount of moisture in the atmosphere. So you have evaporation, you have plants transpiration, condensation, and precipitation, all the process that actually determine how much moisture content you have into the atmosphere. So what would be the possible question from here? So which of the following are not, or which of the following are um, the process for determining moisture content? So that would be the question. So you need to know all these four process to answer those questions. So this is important. In terms of the evaporation, so evaporation depends on some factors. You need to know there are one or two questions on that. So you see the air water temperature. So if the water temperature is higher, evaporation rate would be higher. So degree of saturation of the air, this is a very critical thing. So in the air, if the air is close to saturate, or the air is closer to the saturation point, the evaporation will reduce. If the air is very dry, the evaporation will be exceedingly exceeded. And another thing is amount of mixing, that's mean wind flow. So if you have very windy day, and if you have degree of saturation that's less, you are more likely experiencing the evaporation from the water. So all these three factors that evaporation actually depends on, you need to know. There is a question on that, so and the question might be a little tricky, but you need to know all these three factors that evaporation actually controls or depends. So measurement of the humidity, there are at least two questions that your exam will be from this. So humidity, you need to know the humidity. So we know that when we are watching our weather app, the humidity actually telling us the relative humidity. That's mean the ratio between the moisture content and the saturation moisture content at the temperature of the day or night. So that's the relative humidity we usually the weather app tells us. But there are different way that humidity can be expressed. The first one, the absolute humidity. So what is absolute humidity? It says the weight of the water in a given volume of air. That's mean the absolute humidity is the mass of the water content divided by the volume of air. That the absolute humidity is the ratio between mass and the volume. So you have to remember that. The specific humidity, it's actually the weight of the water in a given weight of the air. That's mean so absolute humidity is mass divided by volume. Specific humidity is mass divided by mass. That's mean weight of the water. That's mean weight of the water vapor divided by weight of the total air. So that's specific humidity. There is other things that in the physical geography, in moisture content, we understand the mixing ratio. You don't need to know for the exam purpose for that, but I'm telling you anyway. The mixing ratio is something that the specific it's related to specific humidity, but weight of the water divided by weight of the dry air, that's the mixing ratio. And the most important, you need to know the relative humidity. So percentage of water in the air compared to the amount of water if the water is saturated. That's mean that the amount of water vapor content right now exists into the atmosphere divided by the amount of water vapor the maximum water vapor or saturation water vapor. At that temperature the air can hold. So if the relative humidity become higher, that's mean the it depends on two factors: the amount of water moisture content into the atmosphere and the temperature. So there is a relationship between temperature and relative humidity. If temperature rises, your relative humidity will decrease. If temperature decrease, your relative humidity will increase. So it also depends on the dew point temperature. That's mean your dew point temperature means at the temperature your relative humidity become 100%. That's called dew point temperature. It's become saturated or condensation is start to begin. In this situation we call it dew point temperature. So in here, measure of humidity, I will explain a little bit more in the next slide. Again, let's see the absolute humidity. So I told you before that mass of the water vapor divided by volume of air. So absolute humidity depends on mass of water vapor by volume. So there is a one sentence I wrote here: absolute humidity does change as air rises and descend. So what does that mean actually? That's mean since absolute humidity is related to the volume of the air, if air rises, the air volume increase. So that's why it says that absolute humidity does change as air rises and descend. So in here you need to remember one thing. Since absolute humidity depends on the volume of the air, so when air rise or descend, volume increase or decrease. That's why the absolute humidity also increase or decrease. I think you have understanding about the absolute humidity. Now, specific humidity and mixing ratio. You see the specific humidity. So mass of the water vapor divided by total mass of the air. So specific humidity is depending on all mass of the water vapor, amount of water vapor you have right now into the atmosphere, divided by the total mass of the air. This total mass of the air include the air mass and the water vapor mass. So that is specific humidity. So you need to differentiate between specific humidity and absolute humidity. So now the mixing ratio, if you see that, it's mass of the water vapor divided by mass of the dry air. So in here mixing ratio is different from specific humidity in the denominator. So total air mass, this include air vapor, and this one the total dry air, only air. So that's why the mixing ratio and specific humidity are different. But if you see that the specific humidity does not change as air rises and descend. So why is that? Because we are talking about the mass. If you go up or come down, it doesn't matter. Mass of the air does not change because it will not involve with the volume. So specific humidity does not change as air rises or descends. But in the previous slide we saw that absolute humidity does change as air rises or descends, but specific humidity does not change as air rises or descends.